Alright guys, Mr. Antonucci here, and this is number 5 from the 2024 AP Calculus AB exam free response question. So, number 5, consider the curve defined by the equation x squared plus 3y plus 2y squared equals 48. It can be shown that dy dx equals this. Okay, so implicitly defined curve, they give you the derivative. Part A, there's a point on the curve near 2, 4 with x coordinate 3. Use the line tangent to the curve at 2, 4 to approximate the y-coordinate at this point. So all we have to do is get the equation of the tangent line, plug in 3, and get the answer. So first thing we need is the slope, so dy dx evaluated at the point 2, 4, and that would be negative 4 over 3 plus 4 times the y value is 16, so that's negative 4 over 19. Then the tangent line is y equals y1 plus the slope, so negative 4 over 19, times x minus x1. Alright, so y of 4 is approximately, or no, it was y of 3. Is approximately 4 minus 4 over 19 times 3 minus 2, which is 4 minus 4 over 19. Now you can actually leave your answer in that form if you want to change it to 3 and 15 over 19. But since this is not a calculator portion, don't worry about simplifying it more than that numerical answer there, or getting the improper fraction. Don't waste your time. So, part B is the horizontal line y equals 1 tangent to the curve. Give a reason for your answer. So, basically, if the horizontal line y equals 1 is tangent to the curve, then the derivative should be equal to 0 when y equals 1. So, dy dx equals 0 implies that the numerator, negative 2x, equals 0, so x would have to equal 0. Now if we go back to the original curve, x squared plus 3y plus 2y squared equals 48, the point 0, 1 should be a solution, because if the line y equals 1 is tangent to the curve, then the point of tangency is going to have a y-coordinate of 1. Since the slope is horizontal, the slope has to equal 0, and the only way that can occur is if x is 0. So that gives us our x-coordinate. So we plug 0 and 1 in. So 0 squared plus 3 times 1 plus 2 times 1 squared equals 5, and that's not equal to 48, so no. There is, so no, y equals 1 is not tangent to the curve. Okay. So part C, the curve intersects the positive x-axis at the point square root 48 equals 0. Is the line tangent to the curve at this point vertical? Give a reason for your answer. So at the point square root 48, 0, the derivative is equal to negative 2 square root 48 over 3 plus 4 times 0, which is negative 2 square root 48 over 3. Since dy dx is not undefined, at the point square root 48, the tangent is not vertical. Remember, vertical lines have an undefined slope, and at the point square root 48, 0, we determined that the slope is negative. So the graph is actually decreasing at that point, not vertical. So part D, for time t greater than 0, the particle is moving along another curve defined by the equation y cubed plus 2xy equals 24. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. At that time, what is the rate of change of the x-coordinate of the particle's position with respect to time? So they've given us a new implicitly defined function, or excuse me, equation, and it's also a related rate problem because they introduced the variable of time, and based on the context, x and y are both functions of time. So they tell us that the y-coordinate is decreasing at a rate of 2 units per second. Decreasing is important because that tells us that dy dt equals -2 units per second. And they gave us the point 4, 2, and they want to know what is the rate of change of x. That's what they're asking for. So the first thing we need to do is differentiate with respect to t our equation. So y cubed would be 3y squared times dy dt plus, now we have to do the product rule on here. The derivative of the first, which I'm counting as 2x, would be 2 dx dt times y plus 2x times the derivative of y, which is dy dt, equals 0. Now let's plug in our values. We know that the y value is 2, so 3 times 2 squared times dy dt is -2 plus 2 times dx dt, which we don't know, times the y value, which is 2, plus 2 times x, which is 4, times dy dt, which is -2. Okay, so 3 times 2 squared is 12, times -2 is -24, plus 4 dx dt minus 2 times 2 is 4, times 4 is 6, -16 equals 0. So you'd have 4 dx dt equals, if you add 24 and 16 to the other side, you get 40. So dx dt is equal to 10 units per second. All right. So hope that was helpful to you guys. And remember, at the time of this recording, the College Board had not released the scoring guidelines, so I don't know the points breakdown, but I have worked through these in advance, and I have other sources or another source that I've referenced to confirm that these solutions are correct. So I hope that's helpful to you guys. Take care.